be all safe with a good health. With you, Ms. Dina Al-Badri, a science teacher for grade 5. Today we will start Unit 15, Forces and Motion. Lesson 1, Forces. Now, what is the meaning of the word force? Force is the push or pull which causes a change in motion. When we start to move something, we change its position, its state from rest to motion. Okay, did you see this picture? Someone make push, so he use his force, and the other one make pull, so he use his force. So in case cause the object to stop moving, start moving, move faster or slower or change direction. Okay, so what the force cause? It make the body to move faster or slower or change its direction. Force are measured with the spring scale. So what is the measuring unit for the force? Spring scale. Okay, forces are measured with the spring scales, and this is the measuring device. The device we use to measure the force is called the spring scale. So what is the measuring unit for the spring scale for the force? Newton. So the first scientist who make us know the force and the meaning of the force, and there is something called the force, scientist called Newton. Weight is a measure of the force of gravity object. So weight, it related to the gravity, but the mass, it doesn't relate it to the gravity. So when I said I want to know your mass, so I want to know the amount of matter inside your body. But when I want to ask you about your weight, so I want to know your mass and your gravity. Okay? Friction force. Friction is the force that opposes motion. It acts between two objects that are touching each other. If it is between air and moving object, this is called air resistance. Sometimes when we start to walk, we found that the air move us in against direction, in a different direction. Okay, so we call this a friction force between our body and the air, and it has another name, air resistance. Okay, when two objects have friction between them, we can feel heating coming off them. All of you with me, start to rub your hand together. What you felt? Faster, more faster. Do it now. You felt hot. You felt there is high temperature between to your hand, to touching body. So when the body are touching each other, they make a friction force. The friction force most of time it produces energy. This is because the energy of motion is being changed into thermal energy. When I say start, wrap your hand together, don't stop until I say to you, what happened? What you felt? Yeah, you felt, there is hot, there is high temperature. Okay, so we talked about the force and friction force. Now we are going to talk about a magnetism. Magnetism is the force of repulsion or attraction between poles of the magnet. All of you know the magnet. Magnet has two poles, north pole and south pole. So when we start to approach two magnets together, sometimes they attract, sometimes they repel each other. Why they repel each other? Because we have something in magnetism from the property of the magnetism. It called the like pole of the magnet repel each other, but the unlike pole attract each other. So we know that every magnet has two poles, the south pole and the north pole. So the magnet has a force or not? Yeah, has the force of attraction or a force of repulsive. The north pole of the one magnet is attracted to the south pole of another magnet. Did you see? So the north pole of one magnet is attracted to the south pole of another magnet. Did you see? South pole, north pole attract. But south and south repel, and north and north repel each other. So all of these repel or attract, we call it a force of the magnet. So what is the meaning of the word magnetic field? A group of imaginary lines running from the north pole to the south pole of the magnet. So we call the magnetic field is the area around the magnet which all the magnetic force appears. Okay, so when I approach another magnet, the meaning of the magnetic field is the area around the magnet which all the magnetic force appears. So in this shape, in this image, we show that there are imaginary lines running from the north pole to the south pole. So all the magnetic force appear in this area. Now we are going to watch the video. This video is talking about the force, the friction, and the gravity. Hope you all understand. Thank you.
Force. We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean? Let's go back to our first example of this video. Here, in order to pass the ball to his teammate, the player must move it. That is, he must interact with the ball to move it in the direction of his teammate. He interacts with the ball by kicking it. the ball and the player interact with each other. In the second example, in order to move the desk from point A to point B, he must interact with the desk. We will study more on these interactions in the future videos. Now, since we are clear with the basic understanding of what force is, let me put its definition in front of you. It states that a force is a push or pull upon an object resulting from the object's interaction with another object. In the next lesson, we will talk more about these interactions. See you there.